Welcome back to the channel. This is Castro. I wanted to make this video as a project update, just to show you how much I've progressed with the build of the 5-axis machine. And also I've received some comments on various social media channels. There's a few comments on YouTube, some through LinkedIn, and a few on Instagram. And I wanted to answer those questions that people asked as well. So without further ado, I will probably strap the camera to myself and then go around the machine and show you what kind of parts have been assembled, and also trying to answer those questions that you've asked. So let me get the camera and we'll continue. All right. I hope this works as a viewing angle. Because I'm going to be moving around, you might feel dizzy, so apologies for that. What I have done so far is that I have assembled the x-axis, which is that one, which I call it x-axis, and also the y-axis. The z-axis should be a lot easier now to assemble. A few things to show you. First is the bolt screw. As I mentioned in the previous videos, this bolt screw is a 15 millimeter diameter, 10 millimeter lead ground bolt screw with double nut, preloaded double nuts. And did I mention it's C0 accuracy grade? And also about these linear guideways, which a few people actually asked quite a lot of questions. This is not something or something that you usually see on typical machine tools. These are quite accurate guideways actually in terms of their tolerances. They come in pairs, so they've been machined together at the same time on the grinding machine that they use to make them. So they are pretty accurate, but obviously if something happens to one of them, then you need to change the other one as well. Regarding the way that I have mounted these, so as you can see here, I've got two granite parallels that they have been lapped together, both on their heights and also on their sort of widths. So they are pretty much identical, and I've measured them on a granite surface that I had, which was a precision lab grade granite surface, and they were more accurate than what my indicator could measure, which was a 1 micron indicator. So they are pretty accurate and pretty similar. Then what I have here is, you can see these plates. So that plate, for example, or that plate. These are ground stainless steel plates, and they have been bolted to this side of the granite parallel, but essentially extending this surface of the parallel upwards so that I can put the rail against it. I hate using shims or things like that because they reduce rigidity a lot. So I prefer to have extremely precision surfaces and then bolt everything together directly without using shims or anything like that. So these now have been directly bolted onto the granite, and because these are also ground underneath, they are very flat. So when these two faces mate, they won't go anywhere. So basically we don't need to use any other pusher type systems to hold these two rails in place in terms of their movement in this direction, because obviously the blocks will be constantly pushing them inwards towards each other. And the same principle of this extending this surface is being used on for example this axis as well. So if you can see here, there's a plate there and another plate there. So this one is my fixed block. These two are the fixed blocks, and these two are the preloading blocks. So basically I've got this surface which again has been ground, or I think it's actually this one is fly cutted or ground, I can't remember. Basically it's got a flat surface, that's what I'm trying to say. The thickness, it doesn't really matter. It doesn't matter if this side is parallel to that side. It's only important that this side is flat. So it's extending this lapped face of the granite. So it's bringing it up, and then I've got these linear blocks that are basically sitting and mating to this face. Then this actual granite piece, I've got two holes going all the way to the other side, and also from the front another two holes going all the way to the other side. So this plate and this plate, opposite side, they are being held together by a very long screw, which is that one. So it's a long M8 bolt, goes from one end, and then I've got two basically nuts holding it together. So these two are sandwiching the granite, and there are another two, one there and another one there, that sandwiches this granite in place. So it's being pushed from those sides and these sides, and what it does is basically giving me this extension of the lapped side of that granite. So now that this is up here, I can put these blocks and push them against this, and then on the other side I've got these two grub screws that are adjusting the preload. To be honest, this is the first time I'm using this type of linear guideway, but I have used the needle rolling guideways before. Someone mentioned the Kern Evo, which is exactly the same thing that we've same principle that we're using here. Those needle bearings, they are extremely rigid, but they can be a little bit tricky to adjust their preload. It's been dead easy adjusting the preload on these, I have to admit. So I've got full contact again alongside the whole length of this block, and I use precision torque meters to adjust the torques of these two grub screws, and for both of them. I have posted a few stories on my Instagram, so if you don't follow me on Instagram, I post small updates about the project. I'll put a link somewhere for the people who don't follow me on Instagram, and every now and then I'll post a story or a reel or something on Instagram showing you little updates, and there's a highlight on the Instagram page showing a few of these assembly processes. One of them was showing how smooth this was before assembling the ball screw, and you should go and check that one out. But what I did was I mounted an indicator, a DTI, up against this surface up here, and then basically using a long lever try to twist this, and also twist it vertically as well, and I had absolute zero movement on the indicator. So that means the preload is being done quite good without any sort of play this way or that way, and also it's super smooth. So you don't really feel anything. You could just like push it with one finger and it just keeps on going. So these blocks and linear guideways, they turned out to be an excellent choice. It's very similar to your the needle bearing system, but obviously now that these have recirculating balls, you can basically have unlimited length. What else? Obviously these are the grease nozzles that will send grease onto the blocks. Everything is lubricated by grease. I don't like oil or anything like that, especially for this type of machine. So it's all grease. As you can see, for example, I've got these copper tubes that are for the ball screws, so the ball screws will be lubricated with grease as well. What else? I've got the ball screw for the y-axis here. I have to basically fix these. These white pieces are Teflon, which are used as a mechanical brake, basically. Then the motor will be mounted here. Then I've got the cooling pads that will go onto here. This has proven to be a nightmare, mounting and moving these hoses. It took me and one of my friends about a day and a half to put these 4 or 5 lines down there and from underneath. And then obviously now we've wrapped them around here so that by the time that we get the energy chains and everything in place, then we can just like feed them through that. There's been some small calculation mistakes, such as this face needs to be sort of ground and removed, some of it, like a chamfer needs to be done on here on this side. So there's been a few mistakes here and there, but overall nothing catastrophic has happened, touch wood, so far. Yeah, what else? Someone mentioned there's a counterbalance somewhere. There's no counterweight or counterbalance. It doesn't need it, actually. When I move this axis forward, like here, which is almost to the end of its stroke, and then all the way back, on the software side, when I looked at the center of gravity only moves by 5 millimeters. I think from here to here, something like that. So 5-10 millimeters it moves when the whole thing is all the way in the back and all the way into the front. This piece, I think it weighs about 60 kilos, just the bed itself, plus all of that is about 70-80 kilos. So isolating it from the bottom piece, I don't think that it will cause any catastrophic vibrations, especially because that is a big solid piece of granite, and it's only holding it in place by I'm holding it in place by 2 plates on those on the sides of the granite to the actual base, the metal base. Yeah, it shouldn't really move too much, and I don't really have any major concerns about that. There are a few things that I need to still mount. For example, this one, which is the cooling pad for the X-axis linear guide. There's another one over here. I haven't mounted that because the scale, the linear scale, will be mounted on that one, so I didn't want to damage it. But that's something that later on I can put it there. There's also the cooling pads for the Z-axis and the Y-axis that needs to be mounted here. So those needs to be done as well. What else? Yeah, there's been a few. The clearances are very tight in this area, especially when I want to mount the Z-axis. We're talking about like 0.5 millimeter between moving parts, so it's a little bit tricky to basically mount everything, especially if you've got giant hands like mine. But I think I've got enough space between the two these pieces to allow me to bolt everything together. Yeah. Also, a few people mentioned about budgets. I don't have any specific number at the moment in my mind. I think I'm going to be spending well above £60,000 with all the enclosure and everything that goes around it, maybe even £70,000. But I've got 90% of the parts now here with me, so that's a good sign. I don't need to really wait for more parts to come in. There's a few things that still are missing, but I've purchased the majority of this stuff. There's a few like those chucks from System 3R. I haven't purchased those yet, but the actual mechanical parts, everything is being purchased. All the machine parts are ready, as you can see. Also the control cabinet, it's now full of components, the drives, the controller, everything is in there, so that's all good. Eventually there will be an enclosure, as I said in the previous videos, so around the whole thing. This whole thing will go into a double glazing sort of an enclosure with double glazing windows around it. There will be a robotic arm mounted on the left side. From the front side you can access the table. So we've got the 4th and the 5th axis table here, and the 3-axis bed over here. Someone else mentioned that you can extend and put a larger piece of table in front of it. Yes, that's absolutely correct. The idea is actually we've got these bolts, as you can see here, and also there's another place for another plate over there, and we can mount a big piece of basically a fixed bed, so we can mount larger parts or maybe a bigger vise or something to grip much larger pieces over here. Then we've got the tool changer system, the mechanism over here. Those parts have been machined. I haven't got them yet, but they will be shipped to me quite soon. Then we've got the I call it a bath. Basically it's a stainless steel bath that will gather all of the coolant. Then underneath, and that space down there will be the coolant tank, which opens up and down, which opens up like that way. Then yeah, that's about it really. I've mounted the Renishaw linear scales, the actual reed heads now. The scales themselves are not mounted, but the reed heads are now mounted, because obviously you couldn't access them later on. So the x-axis and the y-axis reed heads have been mounted. I think I've answered most of the questions, but if you've got more questions, please feel free to add them in the comment section below, and I hope to catch you in the next one. Thank you.